Start recording. I think you're all set. Okay, good morning. I hope this thing helps. So yeah, it's not as bright as it should be. So I mean, it's hard. Like Sunday, it's at 9 a.m. to 4, so we should go through this. Let's see how it goes. I'll give like a short presentation first. Last time we didn't have enough time. A little bit about like what is the big picture of this development, what's going to happen. Then we talk about daylighting simulation in general and radiance mainly right now. Then we start doing some modeling, really simple. Then we talk about when you did it. Then we talk about like radiance skies, radiance materials. And I think by the time we do that and we set up like a simple thing or we open one of the example files, it depends how fast we can go. Then we set that thing up, we press run, and then we go for lunch. And then when we come back, we have more time to check the result and all that stuff and talk a little bit about annual simulation too, which is basically day sim. It's really hard to predict how it will be, and it will be so many stuff for a single day. I totally know that. We're recording this, so this will be available at least inside the school. I don't know if they want to upload it or not. So you can always come back and check if you have any questions, or you can ask. So be ready. First of all, what is Honeybee? So Honeybee is, again, a free and open source plugin similar to Ladybug, but this one connects Grasshopper to Energy Plus, Radiance, Daysim, and OpenStudio. Right now, only Radiance and Daysim connections are available, but the rest is what I'm working on and we are working on. And why this thing matters, why Honeybee, I have that. I think I showed you this slide before, that all the purpose is to get this process of design, evaluation, and optimization. Like you can go through this iteration with less problems. I was reading an article in Harvard Business Review. It was about like the sexiest job of the 21st century is tedious, which is basically, he's not talking about architecture definitely. He's talking about data scientists. And talking about like the process of data science in 5 high level is discovery, wrangling, profiling, modeling, and reporting. And interestingly enough, they have the same problem as we have. He says like the main time always goes in the first 3, but everything is designed for the last 2, like modeling and reporting. And I think Honeybee hopefully helps these 5 steps kind of happens next to each other, except reporting at the end. It doesn't do that much about reporting. Can you turn off that? Just press 0. And it's supposed to be part of Ladybug, but then it started to grow up, so it couldn't fit there. So now it's kind of a new tab, but it's basically using some libraries of Ladybug, and many times it will ask you to let Ladybug fly too when you're running it. I wanted to give some credits. Like, I'm not the only developer right now. I started the development, but I talked about Chris last time too. So Chris Mackey, and we have Siran. So now we're 3, and we have 2 more people right now working on some stuff. They didn't want me to name them, but pretty soon they will have some addition to the project too, and we're looking forward to have more. And it's the project mainly is not running on us, but it's running on a community. And these are like pictures of some people I just randomly selected on the Grasshopper group. It means they're all, but it's just like the fact that everybody's using, they're commenting, they debugging, they tell us what we need to do is as effective as what we do. And interestingly enough, it's not only about technical stuff. So she's the youngest in the community, Michalina, and I know she's watching this, so I put this for her. And she's the one who basically told me that Honeybee is not yellow. And I have to tell it in every presentation to everyone that Honeybee is not yellow. And this is her study about different honeybees, basically to teach me about honeybees a little bit. But now, some serious stuff is this is what Honeybee is supposed to be. So It's a connection between, as you see, Rhino Grasshopper with all that platforms, and as you see, the arrows are both ways. So it means you should be able to start from Radiance, go to Rhino, or you should be able to start from Rhino, go to Radiance. It's not only a single way running from Rhino and then bringing back the results. So the idea is you can start either way and do the work. And as I said, the Radiance and Daysym are out there. And this is how the workflow will look like, kind of. For daylighting, that's what we're going to do. So you create some material, you prepare your geometry, you define the sky, you run the analysis, you can visualize it. And this is how it will look like for energy simulation. You have a mass, you just create the zones, you add the windows, you run the analysis, and you get the results back. And this is a preview of how it will work with OpenStudio. It's the same thing, right? So you have the geometry here. You will have a component, and then this component will generate the OSM file. In this example, I just opened it in SketchUp, but OpenStudio is more than only an SketchUp interface. That's usually something that people don't know. OpenStudio is a platform. They only have an interface in SketchUp. It's a platform. It has an API, so you can use it to connect to all these different simulation softwares using OpenStudio. And that's the idea of like using all this great development that they're doing and join it with the great abilities of Grasshopper in parametric modeling and what it gives you for all the geometry iterations. And here, as always, units are in the side, right? And this is the reason, like, no question about that. And this one, like, if you are not wake up already. Okay, let's do it. So you supposed to read this document, at least the first 2 chapters. I don't know if you did, but this is what a daylight simulation is. Basically, this is all. What you have, you want to render something. You want to simulate some values of daylight, that how much you get in a place, right? So you have it for some test grid, or you have it for an image. But they're both the same idea. You need a building or a geometry, right? And this geometry should have some properties. Then you need the sky, which basically is the light. And then you need some algorithm to solve the stuff between these two. And this is exactly similar on how you run a rendering, right? When you have a rendering, for example, in 3D Max, I don't know what do you use for rendering, but anything. You have a geometry, which will be exported usually as a mesh. And then you apply some colors, and with the color you have RGB, and then you have a specularity and rawness, and then you put some mapping, and then you put some light. So in daylight simulation, that light source is the sky. And then you say run or render or press F5, something, and it does this relationship. It starts to finding the relationship between this geometry and the sky. And based on how much light you get in each point, you will get a rendering, and based on the material and all that stuff, right? So what makes Radiance a little bit different is you can solve this relationship in different ways. And one of the ways is backward ray tracing. And what backward ray tracing means is here. So instead of starting from the source of the light, so many rendering engines, when they want to run, they start from the source of the light. So you have a source of the light. The source of the light, based on a view that you have, it starts like casting all these rays all around the place, right? And then you start seeing the image, because this light goes, and wherever can see the light will be brighter, wherever cannot see it will be darker. But Radiance, how Radiance work is backward. So you have some test points, or you have some pixels that you're looking at, and the ray tracing starts from that test points. It goes upward, or like it goes all around the place. It goes back, and it starts to go all the way to see the sky, right? So if a point cannot see the sky, it means you don't get light for that point. If you can see the sky, it means you get some light from that sky patch based on how much light is available from that sky patch. So there is something really, really important here, that if you don't set up the parameters right, as you have seen here, probably he mentions all this stuff. If you don't set up your parameters right, you won't see the sky. The good example is that shading here. So this is what happens. So you have a test point on your table, right? You say run. What Radiance does is start putting all this rays all over the place. So some of them, like this one goes here, 1. And there is a parameter, they call it AB, which is the ambient bounces. So you get 1 bounce. If you have 2 bounce, it goes here and it dies, right? So this one goes here, it goes inside here and go boom, dies. So for example, like what you were trying to run for your shading studies, I said like minimum of 4. Why? Because if you don't do that, you will get many of the rays, especially like they can't pass your shading device. And that's what happens when people run analysis and they say, you know what, without shading I had something, then I put the shading and all the shadings give me the same result. So it doesn't mean all the shadings working the same. It means your parameters are not right. And I will show you another presentation later today that is really, really good resource to check how every single of these parameters are going to change your results and which one is really important. And it's not something that we can cover today in details, but there are enough resources that you can start learning about it. Okay. Now you know what we need. We need a geometry, we need a sky, we need something to solve this thing between. Radiance takes care of solving the stuff between. The only thing we need is to generate the sky, to generate the geometry, and press run. Simple. Okay, you do it. So let's go open Rhino. And hopefully this time it's not going to crash. You don't have Rhino? Okay. Where are you in the graph? In the graph of technology hype? I can't type in the morning. Here. While this thing is opening. I don't know why Rhino is like this here, and like it takes forever. Okay, we got it. Yeah. Just remember, if you haven't been here, probably something is wrong. And we want to get here, right? So push it. Where are you? You're there? Okay. Yeah. Move faster. So Rhino, type grasshopper. We already have Honeybee installed. I wanted to show you how you can update your scripts without downloading a new version and all that stuff. But I checked yesterday, and the place the school is putting all the user objects is different, so we can't do it today. I'll get that fixed and then send you a follow-up video or note or something. Okay, and we're trying to open Grasshopper. You guys have Grasshopper open? I don't. Something is wrong with this system. It happened last time too. Is this happening in every class? Like you wait like 10 minutes for Grasshopper to be open? 5 minutes? Okay. It's not even here. That's weird. I don't know. I think we tried both. I know what's the difference. So this is 64 bit, that's 32 bits, but like the difference is in the performance of the system, right? So the 64 will work on 64 but never work on 32, but 32 should work the same on 32-bit system and 64. And I think our systems are 64, but last time I tried 64 and it crashed. So I don't know, we can try that too. I think next time I just like let Grasshopper to be open like half an hour before the workshop, so we have it open. While we're waiting, I think you can go ahead and download the example files for Honeybee. So it's here. If you go to Ladybug homepage, like the group page, example files for Honeybee. Download. Are you sure? Yes. Okay. I'm trying hard to open Grasshopper. Okay. Which version is this? Okay, now it's all open. Okay. Let's get one. What's that? To the desktop? Thank you. I did it here too. So let's put it in two different places. In desktop. Okay, thank you. So it's here. So okay, we have this thing downloaded. Sorry because of the headache. So let's not open anything. Just go. Let me talk a little bit about the structure of Honeybee, and then we will get started. It's similar to Ladybug that you had Ladybug tab here. You have Honeybee tab. And what this one helps you to do is preparing the geometry for simulation. So there is a Honeybee, which what it does is similar to Ladybug. Ladybug copies all the information to all the classes and functions to the shared memory of Rhino. The rest is the stuff that you will be using to generate the right geometry for simulation. You have like a single tab only for materials, and what are and it's not all the types of material for radiance definitely, but the most common ones that you're going to use. Then you have a tab for sky, and well, I know you know, like I think sky does matter, and there is a component that lets you watch the sky. This is a radiance sky. And then here, when we have the sky and we have the material, we put a recipe together. What do I call it? We basically tells what we want, and recipe is different simulation types that you can do with radiance and dasim. And here you run the analysis using these two components and check it. You run it, and then you have multiple components just to visualize the result. As usual, like result visualization is as important as running all the analysis and all this stuff, because that's the place that you can start thinking about what you got and what does it mean. Now I want to do the simplest thing together, so you just do it yourself. Then we will open the example file. go ahead and draw a box. Just a simple box. And then bring the box to Grasshopper. So I draw a box. I bring it to Grasshopper. Or use BWrap instead of box. That's the same, but still on BWrap. Okay, now I have this box selected here, right? What we want to do, we want just to render this. We want just to render this geometry. We want to see the box. That's it. Preview off. Oh, and we need to download 2 things before getting it started, but we will do it together. No worries about that. And I don't know if, can we install any new GHA file on these systems without having permission? Have you ever tried? We will try it together. Hopefully, yes. So I have my geometry, right? So do you remember what we need to do? We need to apply some materials. There is a component here, Honeybee create Honeybee surface. So what this thing does is if you insert it in, if you connect it here, it will tell you like you need to let Honeybee fly. So I let Honeybee fly, I let Ladybug fly. And if you have Radiance and Daysym installed, as you have it on your systems here, it won't complain about anything. So it should be fine and it will be flying. But if you don't, if you're using your laptops and all that stuff, it will complain. It will tell you you don't have Radiance installed, you don't have Daysym installed, then you should install all that stuff and come back. Right now we're fine. So now I have Ladybug and Honeybee flying. I just connect this box again here. And for now, just trust me. It just happened. It has all the materials. We didn't do anything, but it just have it, right? Just connect it there. And let me show you something. So the input of this component is what? It will tell me it's a reference geometry. It's a reference BWrap, which is this BWrap. The output of the component is what? It's a closed BWrap, or it's 5 untrimmed surfaces. It basically component exploded this box to 6 different surfaces, and it output them as surfaces. And like when you look at it right now, it seems they're both the same, right? You have some geometry, it gives you some geometry. But what happened is if you go Honeybee and Honeybee Ask Me, the information center, if you connect the BWraps from the input to this, it's actually nothing. Like Honeybee has no idea what this thing is. The output is nothing. But if you connect the Honeybee surfaces, it tells you this surface has a name. It's a random name. And then it says surface type is not assigned. Honeybee thinks this is a wall. And then you go, Honeybee thinks this is a floor, and Honeybee thinks this is a roof. So what happens here is based on the normal, the component checks the normal, and usually like what looks kind of horizontal is a wall. So component understand this is a wall, and it will assign a wall material to it. Where is the wall material? It's here. If you go to the material, there is a component tells you Honeybee Radiance default materials. Just bring that thing in. So where was it? Here. And if you check this component, it has some outputs, current wall material, current glass material, current ceiling, for all the materials. And you see some materials are already assigned. We will talk about like how to read these materials. But you already have this material assigned. And you can change them if you want using these inputs. We will get there. So just what was the concept? The concept is if you're using default kind of generic materials, you don't need to assign any material. You just connect your geometry to this component, and this component will assign all the default material for you. Because if this is a generic wall, why you should go and say this is a generic wall? You already know it's a generic wall. Does it make sense to you? Okay, go ahead. Yeah, I showed you, this is the generic wall. For now, generic wall is the output of this component. It's a RGB reflectivity, so it's a 50% diffuse reflectance wall. Now from this number, okay, you didn't let me tell you later. So this is how you read it. So void basically is the start of the line. Then you have plastic. Plastic is a keyword in radiance that tells it's not a transparent material. It's like it's a not transparent, diffuse, reflecting material. It's a generic material. Like it's not plastic as we use in material, right? A wall material is a plastic. Ceiling is plastic. And then you get the names is 00 exterior wall, which is the name that I assigned. So it's just like the name of the material. It could be anything. And you will see how you can define that. Then let's not talk about 0 and 0 unless you want me. Then you get to 0.5, 0.5, 0.5, which is the diffuse reflectance of this material for red color, green color, and blue color, RGB. And because they're all the same, this wall is a gray wall that has 50% of reflectance. This is how you can read it. And these two numbers are specularity and rawness. That's why I say it's just what you do in 3D Max when you define a material, because this is how you define a material. This is a simple way of defining a material. This is not the only way you can do it in radiance. But this is what we use, and this is what people typically use for simulating something like for daylight simulation in buildings, right? Now let's try the glass. So the glass, void is the same. Now the type is different. It says it's a glass. And then this is the name of the material. Here you get RGB, but now because it's a glass, you get the transmissivity, and it's not transmittance. There is a difference here, but let's not go there today, right? So this is a glass that is 65% transmittance glass. The TVs, the visible transmittance of this glass is 65. This is how you read it. But we will see how we can define it. It's not really complex. And as you see, it's really simple to read, right? So you will be able at some point to write your own material from the notepad. You don't really need any interface. However, you will get the interface. Okay, so now the material is assigned. So we are done with one part, geometry and material. The other part we talked about was what? Was the sky, right? You have different types of the sky, but before selecting the sky, we need to know what we want to run. So we want to run what? We want to get an image. Do you have a question? We want to have an image. So here I go and take the recipe for image-based analysis, what I call it image-based analysis, right? Image-based simulation. And again, it's a component that gives you so many options that you can play with. But if you remember, we talked about it. Like just look on this side, and if there is no underline, it means you really need it, and you only need the sky file. The rest is like the view name. It's already, if you don't input the view name, it will use the default view name. Then you need a section plane if you want. We make a section plane. Then it asks you for the simulation type. Do you want to, simulate illuminance? Do you want to simulate radiation, or do you want to simulate radiation, right? And then the width and the height. If you leave it empty, it will just use the size of your view. And if you want to back up this image or not, and then you have an input for rad parameters, which is what we talked about, the radiance parameters like that AB, AD, AS, all that stuff. So for now, the minimum is what? Is the sky. So I just do assign a sky. And what kind of a sky do we want to assign? We will talk about it later, but for now, just to keep it simple, go and select Honeybee generated sky with certain illuminance level. No. It's just like the size of your camera. And if you want to see like how it works, you can put like a small or big number, like 100 or something. So you just like make it smaller or bigger. So now I selected this sky, which is the simplest sky. So it takes an illuminance value and it generates a sky. So now I have a sky with 1,000 lux. Right? You don't need to do anything. So you just connect this here. We will talk about the sky types. I have my recipe, I have my surfaces, I'm fine. I have my sky, I have my geometries, materials are assigned, I can run it. So go ahead and select Honeybee Run Daylight Simulation. It's here. Number 4, right? Again, you watch here. It's Honeybee Objects, Analysis Recipe, that the 2 things that you need. Then you need to write the RAD file, and that's all you need to get it to work. So just connect your surfaces to Honeybee Objects, connect the analysis recipe to analysis recipe, and then write the RAD. So I need a Boolean toggle. I bring a Boolean toggle. I set it to true, and I connect it here, and I have my RAD files already written somewhere. So a question for you. Why we don't have run RAD as default that you need? Like, okay, you write the RAD file, but you don't have run RAD as default for this component to work. I mean, it's nothing like there's nothing technical about it. It's about like, because that's wrong. You know, you don't run a simulation without checking your inputs. You don't run a rendering without checking your materials, do you? So how do you run a daylighting simulation without even checking your model? Like this is, I think this is a practice that's just like happening over and over. People just run stuff and they don't check anything. So before running, I mean, we ran this. Before running it, I just write the RAD file. And when I write the RAD file, it gives me an output, which is radiance file, right? The address of the radiance file. This is the other thing that you will see over and over in Honeybee. The outputs are usually file addresses. They're not like numbers. They're not something already calculated. And the reason for that is, one, I wanted people to know the different file types. I want you to start learning about different file types. It's not like something magical happens. There is a RAD file which has all the geometry. There is a PTS file which has all your points. There is the RES file which has all your results. That's the reason 1. The reason 2 is you run something for this class, you go back, you have a final presentation, you come back, and for the same simulation, you come to the point that, oh, you know what, I want to change my visualization. Like my view wasn't good, or the legend wasn't set right. So you don't have to rerun everything. You just go find where your files are, and based on that file, you can regenerate everything. You know, you start from the file path. Make sense? We will see how we will do it. But for now, just to see what I'm talking about is connect this panel. Here, you will see there is an address here. So when I said write RAD, what happened was Ladybug unnamed, because I didn't name it, so it put it at Ladybug. The project is unnamed. Then this is an image-based simulation. Then it's unnamed RAD because I didn't name it again. What we want to do is, before running anything, I want to bring this file back into Rhino Grasshopper and check my geometry and check my materials. How you can do it is this component, import RAD. Unfortunately, this component is not good enough to work for really crazy scenes if you have like so many geometries, but for typical stuff, it will work fine. So all you need to do is just like connect the file path to this component, and you will get 2 sets of outputs. The first one is the materials. So now I can see for here I had exterior wall, exterior roof, and exterior floor. And the second one is the list of surfaces that are in the same branch as the materials. If you remember branch, now you know what is a branch, right? Basket, apples. Remember apples? Okay. Apples work? Okay, go ahead. Are you connecting this to this? And do you have this thing set to true? Okay, so probably yours are not running. Let's check why that thing is happening. But for now, what the rest of you are going to do is visualize this. Put all the materials on the surfaces. So this thing, if you preview on this these are the surfaces, right? You have all the surfaces here as the output. Find the center point of these surfaces and put this text on top of that surface so we can go around and check if the material is assigned right for every single surface. You didn't have the Honeybee objects connected. Okay, you did it, or you're waiting for me? So how you can do it is, first of all, you need to find the center point, and if you remember, you use area to find the center point, right? So now I found the center point of this, and if I bring text 2D or text 3D, so I bring text tag 3D, it needs a location, which is this center point, and it needs a text, which is this materials. And because they're branched, they're in the same branch, so all these surfaces will get this material. However, that's only one item, and here you have 4 different items. So location and text. And the scale is a little bit big, so I do it like 0.5. Okay, now you see this surface is exterior wall, exterior wall, exterior wall, interior floor, and this one is exterior roof, so it looks good. You know, so I'm pretty sure that my materials are assigned in the right way. And now I hope some of you at least know how, if you want, you can basically generate these things based on color. You can start selecting different surfaces and color them. Let me show you how to do that because I think it's really useful. For something like this, we have only 6 surfaces, so you can easily see it. But if you have a crazy model, then what you can do is you can select each single branch and color that surfaces. So you type tree branch, and it lets you select the branch. So I connect it here, and I bring a slider because I have 3 branches, so I bring a slider from 0 to 2. Oops. 0. So this will select only the first branch. I copy paste this. Let me move this thing up here and make this thing bigger so you can see. I copy paste this, and I connect the rad surfaces here. So it's not only selecting the material, but it selects the surface for me. Right now, I can just go, so 0, all the surfaces, which material 0, I can see them. And then just as a reminder, you can use preview component if you want to do a color. And then color swatch. Some color for the morning. Let's do it like yellow. Craziness. Okay. So now I can basically check. I can delete this. I can keep watching my output from the rad material and say, okay, this is all walls. This is a roof. This is a floor. You know, if you have like a crazy huge model, it's really helpful. You can just check, and I bet you make mistakes. Like, that's just normal. If you don't make mistakes, something is wrong, you know. Oh, okay. The colors, this thing is red. Well, first of all, I'm watching the geometry in Rhino. So if I hide this, there is nothing. But the reason you have it red, you have this, right? There are different ways to change this. One way I usually do, probably you have seen, is I bring wireframe, VRAP wireframe, which what it does, it gives you the wireframes of the VRAP. So I connect this here. I turn the preview of this thing off, so it shows me the edges only. But if you don't want to do this, I do this because I want some of the surfaces to be wireframe, and some of the surfaces I want them to be really like shaded. But there is a default in Grasshopper too. So if you want everything to look wireframe, I preview on this. Let's talk actually about this area. So this one makes all the previews shaded, but if you click on this one, it will show you wireframe. You see, the problem with this is my surface that I was selecting, that yellow surface, is wireframe 2 now. So I can't see that. I want to see that as a shaded. The other one here, if you do this, it will hide everything. And be careful. I have seen people doing this and then like dealing for an hour, like zooming in, out, like where is my geometry? I lost all my work. So this is the place to check. Go back here. You can set it to shader. And the other thing is like this red color, if you don't like it, for example, when you do a SUMPass, if you check all the SUMPass files, everything is black, even if they're not connected to a color. How that thing happens is, let me first do it wireframe because I want to see that yellow surface. So I connect this to the wires. I preview off this. If you go here, there is a color document preview setting. Click on this, and you can change the colors. The default color is this, is the red with the transparency. You can make it black and add a little bit of transparency. So now, like everything will look black instead of red. Again, where I did it here, up here. Does it make sense? And I put this black here, and then I added a little bit to transparency. And you can do like pretty cool stuff like with visualization. But if you, I mean, definitely you can change the Rhino preview too, but this is one of the things that you can do if you want. You can extend the curves so it will look like a SketchUp thing. So let's do like 0.4. I don't know how big my box is. So you see, like, you can extend, like you can make it sketchy a little bit. It's the real geometry. It's not only a preview. So what I did, I took these curves and I extended the lines on the both ends. Yeah, nothing related to Honeybee, definitely. Okay, let's go back. So now we have this. We are sure that the materials are fine. What I do now is, first of all, I disconnect this because, especially if you have a crazy geometry, it will take a while to load everything in. So disconnect this. When we run the analysis, we don't want this thing to run again. So just disconnect this one and go and run the RAD. And fingers crossed, if you have, I think I checked, so you should be all fine. And before that, make sure like you select a view that you like, because it will render this view. And then run RAD. This window should open, and then it will go away. Did you see that? You didn't even see it? No? It's luminance, right? Because I didn't put any number here, the simulation type is set to 2, so it's luminance. It's usually for grid-based analysis, its default is illuminance usually because you want to get the luminance. For rendering, you want to see what comes to your eye, right? Unless you want to change it. So the default is, you know the difference between illuminance and luminance? Sure? Okay. Now what happened is, you see different outputs here. You get an HDR files. I know it's a little bit of pain, and I definitely could have one input changing name, one output changing name. But again, that's what I said. It's just like
It's you know, it's like even computer games. You can't get to the king level. Everybody shouldn't be able to get to the king level. You play enough to get to that level, right? For simulation is the same. So you should do enough to know what you're really doing. So where you're going to really look. This is something like with Ladybug, it was the same. After a while, when people get to use it for a while, we just make it simpler. And for Honeybee, it will be simpler later. But right now, I want everybody to know what's really happening there. And when you know what's really happening, that's fine to have only a single output. So for now, we don't have a single output. You should know what type of analysis you ran, so which output you should look. And if you don't know which output to look, it's just simple. You just do this. Okay, this is a result. This gives me nothing, or no, there is a geometry. This is the image. So now we want, this is an HDR image. HDR, I think there in that document, the ASIM document, he talks about what is an HDR image, does he? Okay, so they call the other name for HDR is RGBE. So you have red, green, blue, and exposure, I think, if I'm not wrong. So you have 4 numbers. So you not only have the colors, but you have the exposure values too. But you can always convert this to an image. There are a set of components here in number 4 that lets you play with an HDR image. So select HDR to GIF, which lets you convert an HDR image to GIF. So what it needs, you connect HDR file path here, and it will generate a GIF file. So the output should be a GIF file address. What we can do normally, everybody is fine following, like you got the GIF file. So you should be able, if you go to this address, c/ladybug, unnamed, all this stuff, you should have a GIF image. Go there, c/ladybug, unnamed, image-based simulation. Okay, here you go. So there is a GIF file here, which is this one. And I can preview this. You see, you should have it too, right? So it just happened. We render it. You don't get it? Let me check. We can check that. But again, because we have one more download to do, so let me do the download. I'll come help you. So you know, it's such a pain if you want each time when you render something, go look. If you have 2 screens, it's kind of fine, but I mean, it's not the best. Grasshoppers has some components that helps you to visualize an image right on the canvas here, but unless he changed them, you can't input an address. You should copy paste an address, for example. But there is another plugin that lets you do that, and we will go download this, and it's a little bit weird how you download it. So go here and search for advanced charts. So you should see Wish advanced charts and graphs. In Grasshopper 3D page, just search for advanced charts and you will see this. Did you found it, everyone? So if you click here, you will see somebody is complaining about the charts that we have in Grasshopper. And as a result of this, John shared his part of his plugins, which called Embryo Vs. So download this Embryo Vs GHA. And this component will let us visualize all these images like right on the canvas, so we don't have to go back and forth, which is really, really, really helpful. So now go open wherever this file is, show in folder. And here is like, take a deep breath and keep your fingers crossed and just drag and drop here the component. Okay, it's fine. We can, okay, you got it here. Amazing. So you should have it too. So there is one of them is image from path. Everybody has it? So now if you connect the address, you can just see it here. No pain of going back and forth. and then you can scale it too. We will use this over and over for all the image-based analysis, not to go check the file, but it basically reads the same file that you have already on your system. Can someone help Alan? I will show you from the Honeybee. Yes, yes, yes. Yeah. No, it's not. What type of 3D printer do you have? Zprint or the MakerBot? Oh no, it's Zprint. It's not MakerBot. Okay. Let's keep going. When did I say you will have the break? Probably we won't. So we just don't. So let's go all the way to 12:30 because we're supposed to have a break in between, like for 10 minutes something. If you're fine. If you don't, like we can do it still. Yeah, because we started late. Morning. Yeah, let's go all the way there. Because we started late, we're already like behind. So now we generated an image, right? This is the whole workflow. Like, create a geometry, make the recipe, connect it to this component, we run it, visualize the result. Make a decision, do some change, run it again, done. Right? Okay. Again, like I can leave right now, and you can just do it. But we will do it together. So go ahead.
Every time you make some changes, you need to turn the Boolean thing to false and true again to create a like different image.
No, like if for example I do any change to my box here, that basically trigger this component again. For example, let me go and move edge. Where is that? Oh, snapping. So if I move edge and up to here, it will just run it, and here is the new one. So as far as this connection is live, as soon as you change it, it will happen. You know, that's the other thing. Like, the purpose of doing Honeybee and all that stuff is not to generate something that works with a single click. However, if you know it well, you can basically set up everything to run with a single click. My suggestion for you is don't save files, especially when you get the start. I have seen like people make annual analysis file and then connect everything to that. Every single time, just do it. It's just like a process of thinking when you're preparing your geometry too. It's good to have one as a reference or something, but it's not good to say annual simulation and run it. You want to think, like even during the process of creating this model, you think, what are you doing? Like, what kind of geometry I'm assigning, why I'm running this, is the density of the mesh, like test points are enough, is this something that I want to run? You know, this is a process of thinking. after a while, you get good enough to think about all this stuff, even if you don't do it step by step, then that's fine to use some files. But I would say, like, for your works right now, it takes longer, but just do it over and over. Every time, just set up the file. It's a process of thinking. It's just like how you, when you're drawing a design, you're thinking about it. It's the same for simulation. Okay, go ahead and open the very first file. One thing before that. So this component is awesome, but it has a bug. And the bug is if you don't have a valid address, let me do a C / ladybug. If I connect something like this, it didn't go anywhere. So like image.gif. It doesn't do it definitely when I want it does it. But if you have a path that is not a valid path, or if you have an image which is deleted or something, and you leave the connection like this, if you close the file and open it later and the file is not there, it will make your Grasshopper crash in some cases. So before leaving, just always disconnect this component. You know, if you have this Embryo Viz component here, always disconnect it. It will crash all your system, and you will see some like kind of, I don't remember the kind, it's a pink colored thing comes up, or it's red. All your Grasshopper, then you have to close Grasshopper. So to avoid that, always make sure you disconnect this component before closing the file if you're saving it. So I'm not going to save this, just close it. Save, no. Go ahead and open the very first file of the example files. Getting started with Honeybee.